Hello and welcome back to Azure Terraformer. We just finished up Global Azure and I gave a talk on AZ Resiliency and more generally just how to implement resilient systems on Azure. And in my talk, I kind of demonstrated how to use some of the different structures or resources within Azure to implement different resiliency patterns. So I thought I would start a little bit of a series on what the Terraform resources are within the Azure RM provider to implement those different resiliency patterns. So today we're going to start off with loose VMs and just see what we can do with those for starters. Now, I'll be using some of my keep it simple, stupid modules that are not, by any stretch of the imagination, designed to be representations of the absolute best practices in terms of how to do things on Azure, but it does stand up some of the things that you need to set up a simple lab environment relatively easily. So feel free to use these modules, but just recognize that these are not to be confused with the more robust modules that are part of the Azure Verified Module initiative. And they're really designed as helpers to kind of get things up and running so you can kind of kick the tires. So I'll be referencing some of those, and I might even be modifying some of them today as I dig in here. So without further ado, let's dive into the code and take a look. So here I have my root module all set up, and I've taken the liberty to provision it. Just because these bastion hosts can take kind of a while, but I've set up my Keep It Simple network, which I've recently upgraded it to take in an address space. Okay, we're moving up in the world. We don't hard code the CIDR block anymore. So if you go look at this module implementation, I take your address space and then I use the CIDR subnet function to go pick a couple of subnets within that. I assume that I can get /24 basically subnets out of the address space that you give. So /22 is a nice CIDR block size. It's not too big, not too small, kind of Goldilocks size, and it's got 1,024 IP addresses in it. So you do the math. That's 4/24 subnets that you can put in there. Some of the more utility subnets, you probably don't even need a /24 to really get the job done. So anyways, I got this network here. I got a key vault set up. Again, it's a keep it simple, stupid module for key vault. And I dump an SSH key in there so that I can very easily bastion host into any VMs that I create. So this is my Linux baseline module that this thing can actually do a few things, right? So I use Packer a lot, this module allows me to swap out either a marketplace image reference, or I can pass in my own custom image ID. So that's an interesting thing. There's a Boolean flag to enable system assigned ID. I can optionally pass in a collection of managed identities that I would provision outside of the module and pass into the module. Kind of keeping the separation of concerns of this module. And then I'm just grabbing the generic subnet ID that comes out of my Keep It Simple Stupid network, passing that in, passing in the SSH key using kind of a generic admin user, using some D4 V5s, using my rando resource group, and that's pretty much it. So if we go look at this, the implementation of this module, because that's how we're really going to be able to see what the outputs are. There's a couple of inputs that I already have set up. And so you can see source image reference, image ID, VM size, etc. Some of the things I talked about in my presentation are this virtual machine scale set ID and the proximity placement group ID, and we'll get to those in future episodes. But these are probably the most important ones. So these are both nullable. And I can optionally set the fault domain explicitly, or I can set the zone explicitly. And as we know, there are two resiliency modes within Azure. One is called regional, which uses fault domains. And then one is called availability zone based, which uses zones. And so these are the two attributes that allow me to drive that. And you can see how they manifest, onto the resource themselves. They get set here with the zone gets set, and then the platform fault domain also gets set as well. Now you might be saying, well, but Mark, you default these to null. Yeah, if you go look at the documentation of these, if no value is specified, i.e. null, there's going to be a default value set, right? So if you go look at the documentation, it's important to understand what the default behavior is for different attributes, especially critical attributes like these on a particular resource that you're using, so that you know what to do. So in this case, if I don't set the zone or the fault domain, I'm going to take whatever I get, right? Which I believe is just going to default to the platform kind of selecting what fault domain I'm going to be in. So I'm opting not to use the zone, and it's going to default to fault domain based. And we can see what happens here if I just run Terraform apply. Of course, nothing's changed in my code, but we can see that the fault domain is -1. And that's because, as you can see in my module definition here, like where I declare this module, create an instance of this module, I don't actually set the fault domain, right? I don't tell it what fault domain I want it to use. So the input value is -1. Now, this isn't super great because if I go to the portal, I can actually connect to this thing. So here is my resource group, and here's this little VM that I provisioned. And I do have a Bastion host, so I can connect to this thing. And I stored the SSH key out in Key Vault. I know what the user is. I just need to pick the right key vault, which the key vault matches the VM. Yeah. Now there's something you can do from virtual machines that you provision to Azure, and that's read data out of something called the Azure, The Azure Instance Metadata Service, or IMDS. And this is a REST API that's on some bogus IP address that you can just, access using HTTP calls. So I can just type this in. And if I type in the exact command that's correct, in this case, I'm querying details from the CRP or the compute resource provider, and I'm asking it what the platform fault domain is. So, of course, I probably screwed something up. So let me just double check. There we go. And it's a little bit hard to see because literally it's just one character. It's zero. It's this 0 right here. So let me clear that and try that one more time so you can see. And there it is. Again, it's kind of hiding there, right in front of where the CLI starts again. But basically what it's telling me is that the platform fault domain that I'm in is actually 0, or the first fault domain. Now, this, that's nice, but the problem is the Terraform resource outputs the fault domain of -1. Now, if you go read the documentation for the Azure Linux VM, and you go look at the platform fault domain right here, it says that it defaults to -1. Right? Which means that it will be automatically assigned. So unfortunately, when I pass in a null, that is like by design, like I wanted to pass in null. However, what happens is I pass in null, which means the default value is -1, which is telling the Azure platform, hey, go assign it for me. However, the unfortunate thing is that when I output the value from the resource, and we can go look at where I do that in the module, right? So here's the platform fault domain on this resource, and I go output that, and I output the fault domain. I'm pulling it off the resource. Unfortunately, the resource actually outputs -1, which is technically what I input, but it's not actually what the VM is. So that's what we would call less than ideal. Okay, not great, not a great experience. I would prefer if this module, were to output me the actual fault domain that was assigned by the system, by the platform. I understand that it defaulted to -1, but that doesn't help me after this thing's been provisioned. Why does this matter? Well, I may want to use this VM to go, put it into a cluster And I organize the cluster's resiliency configuration based off of the fault domain that it's in. So it's, if you use system assigned fault domains, unfortunately, there's this little issue in the provider. And I'm using a pretty recent provider, okay? I'm not cheating here. This is 3.99. I think 3.100 is the latest. So this is a pretty new version of the provider. I'm getting the -1 out of there. So how do we overcome this? Well, of course, I could just go explicitly set the fault domain. And I'm setting this on the module. And notice I'm going to change it. Like I went to the IMDS and I actually asked what the fault domain is. So I would expect that Terraform is either, when I run plan again, Terraform's either going to detect that the value is not -1 and it's now a different value and it's going to want to change, or it's going to detect that it's not 1, it's 0. And it needs a change. But I'm guessing it's probably just going to pick up on that it's a -1. Let's find out. So that's interesting. So it's not even letting me set the platform. I must have missed that in the documentation. It's not even letting me set the platform fault domain unless I specify a virtual machine scale set ID. That's interesting. So this is intended to be used when you attach it to a virtual machine scale set. Is this in the documentation? Yeah, it does not look like it's actually that this is specified in the documentation. That's kind of a bummer, So really unsuccessful. I'm 0 for 1 here. I really can't set the fault domain explicitly. That's kind of a bummer. I guess I'll have to wait until I work with virtual machine scale sets to be able to do that. Now, let's see if I can set the zone. So I'm going to set the zone to 1. Okay, now this is more in line with what I expected. Remember when I originally provisioned this VM's already out there. We logged into it. We hit the IMDS service from inside of the Bastion host, like being connected through the Bastion host. It was by default, when in the absence of an explicit zone or a fault domain being set, it assumes fault domain based resiliency, and it just automatically got assigned to a particular fault domain. Now here I'm flipping the bit and I'm saying, no, I want to actually explicitly set the zone that this thing is going to be in. That forces replacement. Okay. And so that's what's happening here. So I'm going to say yes. Let's do that. And I probably need to add an output while it's creating this, deleting and recreating this VM. I'll go and add this output because I'm pretty sure the module does return the zone. Let's go check the module. Yeah, so I do return the zone, and it's the zone off the resource. I'm just not piping back out the input variable. Okay. So now we just have to wait for this thing to provision. Okay, VM destruction is complete. Now we're creating the VM. So now we're creating virtual machine extensions, which probably means that the node is healthy. So let's go back and look at that node again. If we go look at this thing now, okay, and it provisioned, but we didn't have the output. So let's output the zone. Okay, so fault domain still -1, but the zone is set to 1. Okay, so now if we go look at this VM out here, let's go check it out. I don't spend too much time in the portal anymore. So sometimes it's kind of hard to remember where things are, and especially they move stuff around a lot. Oh, and look at that. Availability zone is 1. And likewise, if I probably lost this connection, I don't know. Yeah, I got to reconnect here. And it's a totally different VM, so I don't have shell history or anything like that. Dang it. And there you go. We can now see that the hidden number is 1, right? So what we see in the portal is also reflected in the IMDS service that we can access locally from the VM. Now, again, remember, everything that comes back from the IMDS is going to be contextualized to the virtual machine that you're actually on. So the responses are only for the virtual machine that you're on, which can be insanely useful if you have intelligent agents that you're writing, that you want to talk to the Azure control plane from the node itself and see information about it. You get those answers kind of by default. Anyways, so we've successfully changed it to the zone. Now it is interesting that like the fault domain was not, I was not able to set that explicitly unless I was attached to a virtual machine scale set. So next episode, we're going to get into the availability set. We're going to flip this thing back to fault domains, and we're not going to set the zone explicitly. So next time we'll get into the availability set and we'll see what can happen when we start using that thing. And then from there, we'll move into VM scale sets, and we'll probably tackle this, look at what it takes to do a fault domain based VM scale set versus a zone based VM scale set. So this is a good example of kind of a common place of friction where, the documentation may not, show perfectly a complete picture of all the potential conflicts. So that's why it's so helpful to get hands-on and start working with the Terraform provider, digging a little bit deeper. Sometimes you might have to go beyond the Terraform documentation. Oftentimes I find myself having to do that and dig into the actual resources documentation itself, right? In this case, virtual machines and using fault domains explicitly. So, and then coming back and mapping that into Terraform. So anyways, I hope you found this helpful, working with loose VMs and different resiliency modes using fault domains and availability zones, and how to use the Azure Instance Metadata Service to query pertinent information about your VMs once you've logged into them. Stay tuned until next time when I introduce the availability set to this VM, and I'll probably add a couple more VMs to that party just to make things a little bit more interesting with the availability set. So until then, this is the Azure Terraformer signing off.